So although these four have the same point value numbers, I'm going to teach each of them as if I hadn't seen the previous one, so you start to get the pattern. So 3, 4. Write 3, up 4, complete the triangle back to the origin. You're trying to find this value of theta. So this is your answer of theta in standard position. So we know it's a 3, 4, 5. And then I go sine of theta equals opposite over hypotenuse. Cosine of theta equals adjacent over hypotenuse. And tangent of theta equals opposite over adjacent. Okay? I only wanted the 3. We'll worry about the other 3 later. To me, you need to get this basic idea. Okay? So then, and by the way, that means cosecant, 5/4, secant, 5/3, cotan, 3/4. I can use any of these to find that value of theta, but I have to remember that it's in the first quadrant. So what I'm focused on is this angle in standard position. So I need to find this value of theta in quadrant 1. So I'll do the inverse sine. Clear. So, inverse sine of 4/5. Okay? 53.13. Well, the great thing is 53.13 is in the first quadrant, so my calculator told me the right answer. But let's assume it was cosine. So let's do inverse cosine. Inverse cosine of 3 divided by 5. It still told me first quadrant. Great. Inverse tan of 4 divided by 5. Oops, did I do that wrong? 4 over 3, sorry. That's another advantage of checking, is you want to make sure it matches. Well, I got lucky on that one because since all of these were positive, it lends itself to the first quadrant. All right, let's jump down to this one. Negative 3, 4, left 3, down 4, hypotenuse is 5. What I'm trying to find now is the measure of that angle in standard position. So technically what I'm doing is that. So I know that it's got to be in the third quadrant, which means it's somewhere between 180 and 270 degrees. I know my answer needs to be. Okay? So sine theta, cosine theta, and then tan theta. Opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent, where a negative over a negative makes a positive. Okay, so let's make sure you see that negative. I'm going to do the inverse sine of 4/5, of negative 4/5. Now that's negative 53 degrees. Now I want to tell you, if I do negative 53 degrees and I put that in standard position, let me try to move this here. So negative 53.13 tells me it's in the fourth quadrant. So that didn't give me the right answer. But what I can do is use it as a reference angle to help me figure out that one in the third quadrant. And here's what I mean. So I know that if this is my actual angle, this represents my reference angle, and that's 180. So I would go 180 plus 53 is 213, 13. So that would be my angle in the third quadrant. If I didn't use sine and I decided to use cosine, inverse cosine of negative 3, fifths, inverse cosine of negative 3/5, that tells me 126. If I graphed 126 in standard position, that tells me it's in the second quadrant, but we know my answer's in the third quadrant. So we would have to go 180 minus 126.87, and that would tell me the reference angle. And I would then add that, because it's actually in the third quadrant, I would go 180 plus 53.13, which gives me the 213.13. Okay? So plus 180, let's make sure I added that right. Oh, 233. I'm doing awesome. This is why we check. All right. What if I decide to do the inverse tan? If I do the inverse tangent of 4/3, it tells me the answer in the first quadrant. Well, if it's in the first quadrant, that means that is my reference angle. Either way, my value of theta is 233.13. Now let's say you don't believe me and I want to check it. I can take 233 degrees and I can put it in for theta. So I'm going to go sine of 233.13 and I press enter and I get negative 79 cents. Then what I'm going to do is and remember it's estimated, so negative 80 cents. Then I'm going to take the answer and that gives me negative 80 cents. So I know that I'm good to go. Let's do the next one. Negative 3, 4. Negative 3, 4, 5. That means in standard position, my answer is in the second quadrant. Okay? So then I'm going to do sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, and tangent, opposite over adjacent. Now, I've gotten pretty good that I know that when it's positive, my calculator thinks it's in the first quadrant because everything's positive. So maybe I go, well, I know it's not in the first quadrant, so I'll try cosine. So I go inverse cosine of negative 3/5. Because I can use whatever one I want. 126.87. Yes, that tells me it's in the second quadrant. So using that one was good to go. So I did inverse cosine of negative 3/5. And it gives me the answer, 126.87 degrees. Now let's say you don't believe me or you want to check. I could take this and plug it in for tangent. Remember, it's rounded. So I'm going to go tangent of 126.87, and I get negative 133. If you go 4 divided by 3 in your calculator, it's 133. That's how I know that I'm right. Last one, do on your own, hopefully. Write 3, down 4, 5. I know that means that my answer is going to be in the fourth quadrant in standard position. Sine. Cosine, sorry. I should redo that. I'm sorry. It's getting ugly. Sine of theta equals negative 4 over 5. Cosine of theta equals 3 over 5. Tan of theta equals negative 4/3. Remember when I told you the one that's positive will probably end up in the first quadrant? So I'm going to pick this one so that I can get the reference angle. So I'm going to go the inverse cosine of 3/5. And it tells me 53/13. So this one tells me it's in the first quadrant, but it's really in the fourth. So I'm going to use that as a reference angle. Okay? And when I use that as a reference angle, knowing that it's in the fourth quadrant, I'm really going to go 360 minus 53/13. So 360 minus 53.13. Oops. Okay, 360. Minus 53.13, boom, 306.87 degrees. And then I can check it. So I'll do the sine of 306.87, and I get negative 79 cents, which is like 80 cents, which is 4/5. Okay? Now, let's do the more difficult ones. Left 4, up 8, Pythagorean theorem. Okay? So I know that I can just kind of simplify it. I'm going to fake it a little bit. Actually, I'll just deal with it. So I'll go 4 squared plus 8 squared equals c squared. 16 plus 64 is 80. Rad 80 is 4 rad 5. Now I know that I'm going to save myself some time by dividing by 4, negative 1, 2, rad 5. Okay? So sine of theta equals, cosine of theta equals, tan of theta equals. Okay, sine is 2 rad 5 over 5, just simplifying it, negative rad 5 over 5, and negative 2. I know it's in the second quadrant, so I could use this as knowing it'd be in the first quadrant and make it a reference angle. So I know that it's going to be in the second quadrant. So I need to figure out that. So my answer needs to be between 90 and 180 degrees. So what I'll do is I'll do the positive one. I like to keep it interesting each time and change how I do it. Inverse sine of 2 rad 5 and parentheses divided by 5. And I get 63/43. It's weird how that worked out to be the other. Oh, because it was the same ratio. So I get 63/43. That 63/43 represents this reference angle. So I need to go 180 minus that. So 180 minus 63.43, and I get 116. So the value is 116.57 degrees. Let's jump to this one. Right 4, up 8, Pythagorean theorem, 4 rad 5, blue, 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 sine. They're all positive because it's all in the first quadrant. So I know that no matter what the calculator tells me, it'll tell me the right answer because it's positive. 2 rad 5 over 5, rad 5 over 5, 2. So when I do, I'll do the tan, inverse tan, because that's a lot easier. And it tells me 63.43. Boom. If you look, it's in the first quadrant, so that gave me the angle right there. 63.43. Okay? The next one, right 4, down 8. Let me just do this. I'm going to simplify it and make that a 1 and a negative 2. And then we know that's rad 5. So now what we're doing is trying to find the measure of the angle in the fourth quadrant. Okay, let me do that all in pink. So sine, cosine, tan. Okay, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and this one is opposite over adjacent. Okay, I'm pretty good now, so what I'm going to do is I'm just going to use the one that I have to least plug in. So the inverse tan of negative 2, and it tells me negative 63.43. Negative 63.43 is in the first quadrant, but that's my reference angle. So I'm going to have to go 360 minus 63.43, and I get 296.57. So I got lucky on that one, and it told me the right quadrant. But either way, it's all based on the reference angle. Last one, left 4, down 8, negative 1, negative 2, rad 5, sine, cosine, tan, negative 2 rad 5 over 5, negative rad 5 over 5, and 2. I know, let me move this up, that I'm finding third quadrant in standard position. So I'll do the inverse tan of 2, which I think will tell me the first quadrant because it's positive. And it's 63.43. So that tells me this reference angle right here, 63.43. Well, here's 180 degrees. If I go to here, I'm at 180, but I have to keep going. So I'm going to add those two together. So 180 plus 63.43 is 243 degrees, 0.43. Okay? I know that that works out because it is in the third quadrant. Let me check it. I'll take it. I'll plug it in for cosine because maybe I just made a mistake on tan. So I'll go cosine of 243.43, enter, and I get negative 44 cents. So when I plug in negative rad 5, negative square root of 5, and I divide it by 5, it better be 44 cents. It is, and I'm good. Page 1.